Hi friends, so today we are going to discuss about LM358 op-amp IC, which is having 4 inputs, 2 inverse and 2 non-inverse inputs. 2 and 6 are inverse and 3 and 5 are non-inverse inputs. So we are going to use half of this IC, that is the second and the third pin, for our inputs for comparing the two voltages. So this design mostly we can use for 6 volts or 12 volts lead acid battery charging purpose. So here I gave 12 volts input for the IC, and this one 24 volts, reduce it to 15 volts using buck converter, and this voltage input I am using for the comparison at the pin level 3. So I set this potentiometer at 2.45 volts. So this voltage 2.5 voltage is going to non-inverse input of this IC, third number pin, and at second number pin we have reference voltage, that is 2.5 volts again from this TL431 regulator diode. So here in this design at pin number 2 and pin number 3 it keeps voltage identical, that is 2.5 volts that we set with this potentiometer which is coming from this battery or buck converter, and the pin number 2 again 2.5 volts reference which is coming through this resistor from this TL431 regulator diode. So when voltage drops at pin number 3, this LED glows. So in practical scenario, if we use this as a battery, when voltage drops less than 14.5 volts, then voltage will be dropped at pin number 3 and the LED starts glows. So now see the at pin number 3 the voltage is 2.3, so it is glowing. When we connect these two positive terminal, now it is showing 14 volts. So let's increase the voltage. So when it reached to 14.4 volts, the LED stopped glowing. When we reduce the voltage again, it is going in negative direction and LED getting power and it glows. So take an example of this register R1. And this Schottky regulator diode D1. This is TL431. This register is important here. I put 4.7 kilo ohms, 4K7 register here. So how to calculate this register here? So R1 sets the D1 base current. Here we need minimum 1 milliamp current to this diode. So this is set at the minimum voltage input for a 6 volts if you want to use this design for 6 volts battery. So let's see the connection. I'm just switching off it. So the yellow wire is the positive wire, black negative. This 18 volts input I gave here, the remote. So this is the battery minus voltage. So this is the 15k resistor, 100k resistor which are connected to this potentiometer. So this yellow wire is connected to pin number 3 of this IC, and the reference voltage is given through 47k resistor to pin number 2 here, and 1k resistor from pin number 2 through 104 PF to pin number 1. So pin number 8 in the IC is the VCC. So we need to give input voltage at pin number 8. Pin number 4 in the IC is the negative. So we need to connect it to ground. So this is how it is connected to ground, and 104 PF is for voltage stabilization at IC level. And this is the diode TL431 or K431, anything we can use. And this is a 50k potentiometer. Let's see the IC. This is LM358. So this is a dual channel operational amplifier IC. So pin number 1 and pin number 7 are output pins, and 4 minus, 8 plus voltage, 2 and 6 are inverting inputs, and 3 and 5 are non-inverting inputs in this IC. So you can check datasheet for more information for this IC. So this design probably can be used for any 6 volts or 12 volts battery charging purpose. So only change we need to do is we need to use this LED place we need to use one P-channel MOSFET. That's it guys. I think this will help you guys for understanding LM358 IC functionality, and you can use in multiple ways using this design.